Alright, so here's that last video. Let's start with number 73. We're simplifying these factorial expressions. So here's one. And so to start, let's just write out what this top thing is. Okay. And over here's 4 factorial. Okay. I'm just going to write 8 factorial. You'll see in a second. If you don't see it right now, you'll see in a second why. But first I want to say, look here. This is all multiplied together. We're about to cancel things out, but it's only possible because we're multiplying and not adding anything on. So I know we've had our struggles with that in the past, so don't forget that. It's only because each of these things is a factor of the numerator and the denominator respectively. So 11 is a factor, 8 is a factor of the numerator, 4 is a factor of the denominator, and we can only cancel out common factors. So don't forget that. Okay. So now let's take a look at this. What's 8 factorial? 8 factorials is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So here is 8 factorial as well. This is 8 factorial, and it cancels with 8 factorial. Okay, so all that's left is all this. Now we could have gone and done 4 first. We're going to do 4 factorial with 4 factorial, but then we're left with 8 factorial to cancel out of all of this, and that's a little weird. So just cancel the biggest one first, the best way to go. Now we can take a look here. This is 4 times 3 is 12. So this is 12, and this is also 12. This 2 can cancel the factor of 2 in 5, or in 10, and this becomes 5. So 11 times 5 times 9, 495. Okay. Let's just go right here to 76. It's n plus 2 factorial over n factorial. Okay, so this is just to, again, I guess improve our comfort level with this notation of n and n plus 2, and it's a little weird to start with, but you'll get the hang of it. Well, let's start at n plus 2. It's just some number, and n plus 2 factorial means n plus 2 times every other number that's less than it. So what's the number that's right here? 1 less than n plus 2. It will be n plus 2 minus 1, so it would be n plus 1. And then the next one would be what? n plus 1 minus 1, so just be n. And then we multiply that by n minus 1, and so on down to 3, 2, 1. And on the bottom, what do we have? We have n times the next number less than n minus 1, times n, 1 less than that would be n minus 2, 3, 2, 1. So we have n factorial and n factorial. n factorial cancels with n factorial, and all that's left is n plus 2 times n plus 1. All right. Let's look at 79. So this is summation notation. This is the Greek letter sigma. It starts with S, so we like to use it for summation notation. What this is telling me is basically going to be the same as writing the first through the 5th term. But again, this is summation notation, so we're going to find the sum of all those terms. So we're going to write down the first 5 terms, then we're going to find the sum of all of them. Okay? So the first 5 terms start at 1 because that's what this is. I equals 1 tells us start at 1. Sometimes it'll tell us to start at 0, sometimes it'll tell us to start at 5 and go to 7. Okay? But it says here to start at 1. So we put a 1 in here. 2 times 1 plus 1, that's 3. Okay? Now we go keep going up until we get to the 5th term. So let's put a 2 in here. 2 times 2, that's 4, plus 1, that's 5. 2 times, the next one is 3, that's 6, plus 1, that's 7. You can see now the pattern is we're getting the next odd number. Okay, let's see. This is the 1st, 2nd, 3rd, 4th, 5th term, and that's all they want, from 1 to 5. So let's see. We've got a 10 here, and how about a 16 here, a 9 here. So these together are 25. These are 10, so 35. All right, let's try 86. Okay, and look, like I said just a moment ago, here they wanted us to start at the 1st term and add up all the way through the 5th term. Here they want us to start at the 3rd term and add up all the way through the 5th term. Okay, so let's put a 3 in there to start with, 3 in there for J, so 1 over 3. We're going to add on 1 over the next thing, which would be a 4. Put a 4 in there, we get 1/4. And add up 1/5. And now we've gone all the way to the upper limit, we call it, lower and upper limit. Okay, so now we need to add these together. Of course, we need a common denominator to do something like that. So the common denominator is going to be, well, it's just going to be 3 times 4 times 5, and that is going to be 60. Yeah, 60. So how many 60ths is this? It's 20 60ths. How many 60ths is this? 15, and this is going to be 12 50ths or 60ths. Okay, so this is 35 47 60ths. There you go, there's number 86.